video is one of a series covering the released Ohio State math questions between 2017 and 2023. Expressions and equations make 1/3 of the test questions. Perform operations with numbers expressed in scientific notation, including problems where both decimal and scientific notation are used. Use scientific notation and choose units of appropriate size for measurements of very large or very small quantities. Example, use millimeters per year for seafloor spreading. Interpret scientific notation that has been generated by technology.
Hello and welcome. Let's see what we need to know before we get to the questions. Scientific notations are used for very large and very small numbers. So this large number here is going to be written in this format. This decimal number times 10 to the power 6. And we will see how this is done shortly. This very small number is going to be written in this format. 2.34 times 10 to the power negative 7. 10 is called the base. These are called the coefficients. These are called the exponent. So the general form for a scientific notation is a times 10 to the power n. A is a decimal number greater or equal than 1 but less than 10. 10 is the base, n is the exponent, and it's an integer. Now here's what you need to remember. Only one digit to the left of the decimal point and must be between 1 and 9. So it can't be 0. One digit, 1, 2, 3, 4, or up to 9. So let's see first if we can recognize these as whether they are written in scientific notation or not. This one here, it is in scientific notation. Yes. This one here is not, because to the left of the decimal point, 15. You can't have more than one digit and it's none, it should be not 0. That's no. This one here is yes. This one here is yes. This one here is no, because I can't have only a 0. It has to be 1, 2, 3, 4 up to 9. So that's no. So let's see some examples now how to convert decimal to scientific notation. If the number is greater or equal than 1, it will end up having a positive exponent. This number here, we're going to write it into scientific notation. So I would imagine that there's a decimal point here, and I'm going to start moving it in this directions to the left. 1, 2, 3, 5, 6, 7. So I moved it 7 places to get it to this point here. Then this would be equal 3.470000 times 10 to the power 7. I moved back 7 position, that produces 10 to the power 7. So it's more like I divided by 10, 10, 10, then you have to multiply to get back the original number. You don't need to put these zeros here, so it will be 3.47 times 10 to the power 7. Now if the number is less than 1, we end up having a negative exponent. This is less than 1, so I have to take this decimal point, move it in this directions to here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm multiplying by 10 every time I move it here. So 9, 10 to the power 9, then I have to put 10 to the power negative 9 to get back my original number. Converting scientific notation to decimal. Now this is an easy stuff. This is scientific. I want to turn it into a decimal. So I'm multiplying this number by 10 to the power 7. So I need to move this decimal point 7 times to the right. I have already 2 here digits, so I have to add 5 digits. That gives me this number. This one here is really a small number, and I need to turn it into a decimal number. So I need to move this decimal point to the left 8 positions, 8 places. Since I have 1 already here, so I have to add 7 zeros. 1, 2, 3, 4, 5, 6, 7. It gives me this number. Now adjusting the exponent, sometimes when we add, we will see shortly when we add two numbers in scientific notation, we end up having sometimes a number that is not in scientific notation, and we need to adjust the exponent to turn it into a number in scientific notation. For instance, this one is not in scientific notation. Obviously, I have 2 digits here. I'm only allowed to have only 1. So I have to divide this number, this by 10, divided by 10. And then I have to multiply this by 10, which means I add 1 to the 7 here. It gives me 2.8305 times 10 to the power 8. And this is another example. This is obviously is not in scientific notation. I have to move this decimal point 2 positions to the left. So I'm dividing by 10, so I have to multiply this by 100, meaning adding 2 to this exponent. I will get this 7.8402 times 10 to the power negative 3. Another example, this here is not in scientific notation, obviously. You need to adjust it to make it in scientific notation. So I'm taking this decimal point times 10, times 10, times 10, 1, 2, 3, 4. So I need to subtract 4 from the 7. I get 2.83 times 10 to the power 3. Another example, 1, 2, 3, 4, 5. So I need to subtract 5 from here. I get 7.84 times 10 to the power negative 9. Now we are going to see how we add 2 numbers in scientific notation. First, we consider the numbers having the same exponents. So what do we do here? We add the coefficients, keep the exponent, convert to scientific notation if needed. That's what I was calling it, adjust the exponent. Here's an example. We're adding these 2 numbers. They have the same exponent, so we just add these 2 numbers. I get 8.73 and keep the exponent 10 to the power 4. There's no need to do any adjustment, it's done. Here, let's add these 2 numbers. I will get 13.93 times 10 to the power 4. So obviously this is not in scientific notation. So I'm dividing this by 10. I have to add 1 to this. 1.393 times 10 to the power 5. Here is another example. Same powers here, same exponents. So I add these 2 numbers, this and this. I get 13.93 times 10 to the power negative 4. Now I'm dividing this by 10, I multiply this by 10, which means I add 1 to it. So I get 1.393 times 10 to the power negative 3. Now, if we have a different exponents, that's a little bit more complicated. So the method 1 is convert the numbers to decimal numbers, add them, then convert the result back to a scientific notation. Method 2, adjust the exponents and add. We will see how these work. These 2 numbers are not in, they don't have the same exponent, so you can't really add them. You can't really do anything about that. You have to turn one of these to be the same as the others. It's easier if you take the small, although you can do it with the other one, if you take the small one and turn it into 6. So now, the first time I'm going to use I'm going to convert both of them to decimal numbers. So this one here to the 10 to the power 6, so I'm moving this 6 position, so I'm adding 3 zeros. This one here, I'm times 10 to the power 4, that's 4 zeros, so I add 2 zeros. Add them. Now I need to do this, turn it back into a scientific notation. Your decimal point is here, 1, 2, 3, 4, 5, 6. 3.5653 times to the power 10 to the power 6. Another example, Now we're doing it. This is the first method. We did using it. We converted them to decimal numbers and we added them, and then we converted back the answer to a scientific notation. Now here I'm going to change one of these powers to be the same as the others. Easier to take this smaller of the two of them. This is smaller than this, so I need to make this 6, which means I'm timing this by 10 to the power 2. I have to divide this by 10 to the power 2, so I'm going to move this to the back 2 positions. So now we have the same power. Then I can add this number and this number. I get 3.5653 times 10 to the power 6, which is the same as we did before. Here's another example with negative powers. So first, if you want to do it using decimal numbers, this to the power -4, so I'm moving this 4 positions to the left, so I'm adding 3 zeros, see? This, I'm moving it to the power -6, I'm moving this 6 positions to the left, adding 5 zeros, 1, 2, 3, 4, 5. Add these two numbers, and now I need to make this in scientific notation. So this decimal point, 1, 2, 3, 4, 10 to the -4, okay? Now, if you want to do the method 2, so this one is smaller than this, so I'm going to use this. I need to turn this into -4, so I'm multiplying this by 100. So I have to divide this by 100, see? Now you have the same powers, same thing. Now you can add these two numbers, and you get this answer, which is the same as the other one. Now, multiplying two numbers in scientific notations, that's easier than adding. So multiply the coefficients, add the exponent. That's the only time when we add the exponent. Convert to scientific notation if needed. Example, I'm multiplying this number times this number. So I multiply these two numbers first, keep the negative, it's a negative. So I'm multiplying these two numbers, and then I have to add 4 and 3, 7. I get this minus 18.305 times 10 to the power 7. Now this one is not in scientific notation, so I have to move this to the left. So I divide it by 10, I multiply this by 10. 8, I added 1, see? Here's another example. So you multiply this times this, and you add these two powers, two exponents. So this 10 to the power minus 10 plus 6 is 46.911 times 10 to the -4. Again, this is not in scientific notation, so I have to divide by 10. Multiply this by 10, you're adding 1. Adding 1 meaning negative becomes -3. Now we get to the questions. This first question was in 2022. It's a level 2 questions. Every time you see these pictures, you may pause the video and do the problem on your own and come back and compare it with the solution. The current population of a city is this in scientific form, people, and the city is expected to grow in population by approximately this people next year. Which is the expected population of the city next year? So obviously this is an additional problem. So you have to add these two numbers. Now, if you look at those, don't look at those questions, just add the numbers and then you see what you get. So they're confusing you here. You will see this -9 in the power 9. So let's not look at this for now. So let's take this and we're adding these two. Now, to add these two, you can have either if I am going to change this into a 5, which means I multiply this by 10, I have to divide this by 10. Okay? Add them, and you look at it. Is it right here? See, this, it can't be 9, so you're not adding these two here. So you can't add 4 and 9 when making an addition of two scientific notation numbers. So this here, if you want to do it using turn these two numbers into decimal numbers, you can. This one will be this. Remember, 10 to the power 5, that's 5 zeros. You have already 2, you added 3 zeros here. 4, you have 1 digit here, you add 3. Add them, and then you have to go back and see how much is this in, what is this in scientific notation. So you have a decimal point here, 1, 2, 3, 4, 5. 10 to the power 5. Okay? This was the only question in 2022 on this standard. This question in 2019, that's a level 2 again, and let's read it. An ant weighs 8.8 times 10 to the power negative 6 pound and can carry objects up to 5,000 times greater than its own body weight. What is the greatest weight in pounds the ant can carry? Express your answer in standard form. Now here they're asking you to express your answer in standard form, in decimal form. So clearly this is a multiplication problem. So you are multiplying 5,000 times this. So this will stay as is for now. We are multiplying 5,000 times this. You get 44,000 times 10 to the negative 6. So you have a decimal point here. You move it 6 positions to the left. 1, 2, 3, 4, 5, 6. You get 0.044. So that's the answer. Now, if you want to do it in this way here, 5,000 times 8.8 times 10 to the power negative 6, you can write this 5 times 10 to the power 3 times 8.8 times 10 to the power negative 6. So you multiply 5 times 8.8 is 44. You add these powers. Now we're multiplying. We're adding these two powers, negative 3. So when you have that negative 3, so your decimal point is here, 1, 2, 3, you get this here. This was one of 3 questions in 2019 on this standard. This question is interesting. It says a scientist estimates that there are 2.2 times 10 to the power 7 walleye in Lake Erie. That's kind of a fish. The total volume of the Lake Erie is 4 times 4.83 times 10 to the power 11 cubic meters. A pool with a volume of 200,000 cubic meters is built to model the lake. How many walleye should be put into the pool to model the condition in the lake? Solution. You have to organize your work here. So I'm going to put number of walleye and volume. In the lake, they are giving me this, how much we have fish, and this, the volume of the lake. Now, the pool that we are building, I know the volume, but I don't know how many walleye I need to put in it. Now, this is, you use cross multiplication, this times this divided by this. This times this divided by this gives you x. So x is equal to 200,000 times 2.2 times 10 to the power 7 divided by this. So now I'm turning this into a scientific notations. That's 2 times 10 to the power 5, so I have 5 zeros. So now I multiply 2 times 2.2, and I add the 5 and the 7, okay? 4.4 times 10 to the power 12 over 4 times 83, 4.83 times 10 to the power 11. So if you do the math, you get about 9.1. So you can't really have 9.1 fish. So your answer could be 9 or 10, and the department accepted either one of these answers. So you can say x equals to 9 or x equals to 10, or you put 9 or 10 here, because I coded x here. This was one of 2 questions in 2017 on this standard. Example number 4. Now, the following examples are practice tests, okay? They are all considered as level 2. So we are adding these two, basically, okay? We are adding these two numbers in scientific notation. We're adding these two numbers. So first I'm going to turn this into 5, which is I multiply this by 10 and divide this by 10. You get this. Add them. 2.53 times 10 to the power 5. Right here. That's one way of doing it. Now, if you want to turn them into decimal points here, it's fine. You get this. You get this. Add them, and now you need to convert them back to convert the result to scientific notation. Your decimal point is here. 1, 2, 3, 4, 5. Every time I go to the left, I divide by 10. Then I have to multiply by 10 not to change the value of the number. So 2.53 times 10 to the power 5. Here's another example, the same thing. We are going to add these two numbers. So I'm going to take this 3 and turn it into 4, okay? It's better always to use the smaller of the two exponents. So to make this 4, I have to divide this by 10, multiply this by 10, 0.46 times 10 to the power 4. Now you add these two. You don't add the powers. You add these two, and it's 1.96 times 10 to the power 4. If you want to do it, now you might ask, could we have started with this 4 here? Yes, you can. So if I want to change this into a 3, this 4, if I want to change it to a 3, so I am multiplying this by 10 and dividing this by 10. So you get 15 times 10 to the power 3. You add these two, you get 19.6 times 10 to the power 3. Now this is not in scientific notation. Divide by 10, multiply by 10, 1.96 times 10 to the power 4. So we have some extra work to do if you choose the other way around. It's always recommended to start with the smaller of the two exponents. Here's another example. Adding these two, I need to turn this into a 7 here. So divide this by 10, multiply this by 10, add them 5.7 times 10 to the power 7. Here's another one. We do the same thing, 3.61. Now this one is smaller than this, so I'm going to use this. So I divide by 10, multiply by 10. Divide by 10, moving the decimal point 1 position, okay? Now you add these two, 3.84 times 10 to the power 9. This example I added because all the examples provided were having positive powers, positive exponents. So I wanted to use one with negative exponents just to give you some practice. So I'm going to add these two. Now, which one is smaller here? This one is smaller than this one, so I'm going to turn this into a negative 8. So which means I am dividing this by 10, moving it, and multiply this by 10. I get this. Now you add these two numbers, and you get 2.661 times 10 to the power negative 8. Now another way here, you can change, if you like, if you prefer, you can change this number into a decimal number, standard form. Change the other one into a decimal form, line up the decimal points, add them up. Now the problem is you want to turn this back into a scientific notation. This point, you're multiplying now. 1, 2, 3, 4, 5, 6, 7, 8. We multiplied by 10 to the power 8, then I have to divide by 10 to the power 8, which is 10 to the negative 8. Okay? Question number 9. This is a very interesting question. The density of an object is given by the equation. The density is the mass divided by the volume. A scientist has evidence that a newly discovered planet has a mass of 7.0 times 10 to the power 10 to the power 24. That's the mass, kilograms, and a volume of 3.5 times 10 to the power 12 cubic kilometers. What is the planet's density? I mean, this is a division question. So the mass is 7.0 times 10 to the power 24. The volume is 3.5 times 10 to the power 12. Now, when you want to divide this, you divide this divided by this, gives you 2. And when you divide this divided by this, that's 24 minus 12. 24 minus 12, 2.0 times 10 to the power 12, and you have it right here. Okay, very interesting. The last question is it was given on this last year, spring 23, question number 37. It's a level 3. Mr. Miller presented his class with the following equation. What are possible values of P and Q? When they tell you possible values, it might be more than one option, okay? So the easiest thing I see, I can do this with is, see, I can multiply these two numbers here and equate that with 1.5. And then 4 plus Q would give you the 8 here. So remember this formula, we just used it earlier also. 10 to the power m times 10 to the power n is 10 to the power m plus n. So now 7.5 times P is equal to 1.5. If you multiply this times this, as 4 plus Q is equal to 8. You have two equations. This one will give you P is 0.2, and this one will give you Q is 4. So that's an answer that is acceptable. Now you can notice that we can play with this here. I can enlarge this and decrease this. So that's one option. So 1.5 times 10 to the power 8, I can consider this as 15 times 10 to the power 7. So I multiply this by 10, I divide this by 10. So not to change the value of the number. So now when you do this, now you say 7.5 P is equal to 15 now. And now obviously the other will change. Now 4 plus Q is equal to 7. So from here you get P is 2, Q is 3. So that's another option. So in fact there are an infinite number of solutions. This was one of 4 questions in 2023 on this standard. So this standard is important to understand and be sure to do it right. And that's it for today. Thank you and see you soon.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.